In this video, we're going to go over a classic problem involving a bigger rectangle and a smaller rectangle within. And it's all about thinking simply. Let's check out what that means. So the instructions say, find the area of the shaded region. The shaded region, so I didn't waste tons and tons of ink and a marker, are this area right around here. So it's the area within the big rectangle, but outside of this small rectangle. And so here's the thing. If you're finding the area within that big rectangle, but outside the small rectangle, that's what you should be thinking about. The algebra is just there to distract. And this is a perfect time and a perfect kind of problem to exercise your problem-solving skills. Problem-solving skills, one of the biggest problem-solving skills, is recognizing when to focus on specific information and when to just kind of leave it and come up with a general idea and exercise that general idea. So what the heck am I talking about? What I'm saying is think simple first. So if we want the area of the shaded region, ignore the algebra and think of this as, I want the area of the big rectangle without the small rectangle inside, so taking it out. So that's area of big minus area of small. So I'm literally just going to write area big minus area small. That's the main idea. And now what I'm going to set about doing is finding the expression for the area of the big rectangle and the expression for the area of the small rectangle. Well, I know that the area of a rectangle, some of you will know that as length times width, which is the same as base times height, right? For a lot of people. So I typically think base times height. So I'm going to take the big rectangle, which will be 4x plus 7 times 3x plus 5. That's base times height, right? So I've got area of big, so that's going to be 4x plus 7 times 3x plus 5. And we'll get an expression for that. Then what I'm going to do is I'm going to line this up. Well, you can do it vertically or horizontally. It doesn't really matter. I guess I'll do it horizontally here. So we have that. That's the area of the big now. And I'm going to subtract from it the area of the small, which is going to be this base, 3x times x plus 4. So that's 3x times x plus 4. That expression right there was generated from the simple idea. Now all we've got to do is simplify. So the geometry of this, the problem-solving part of this, is done at this step. You start simple, area of big minus area of small. You evaluate in those ideas, the base times the height, minus the base of the small and the height of the small. And that now satisfies this main idea. So now all we have left to do is algebra. It's beautiful. In fact, if you have 4 or 5 of these practice problems, I'd get to this step and then go on to the next one and get to this step again, because that's the new part. This is old stuff. Let's do that old stuff. Okay, so now that the word problem translation part is over, we'll just FOIL. So 4x times 3x. I'm not going to show the arcs here. If you need to see that or you need more specific foiling instruction, go to an earlier video on how to FOIL, how to distribute, multiply binomials. So 4 times 3 is 12. X times x is x squared. 4x times 5 is plus 20x. Inner, 7 times 3x is 21x. And then outer, 7 times 5 is 35. That's a beautiful thing. Now we'll do 3x times x plus 4, right? So I've got 3x times x, that's going to be minus 3x times x is minus 3x squared. Minus 3x times positive 4 is minus 12x. So again, we know this expression is correct based on our concept. Now we're just doing algebra and rolling. We're now going to combine like terms. We have 2x squared terms, that'd be positive 12x squared, and minus 3x squared is positive 9x squared. Then we've got some x terms here. 20x and 21x is 41x. Minus 12x is going to be, let's see, 29x. So that's once you combine all the terms. So that is pretty sweet. And then we have one constant remaining, plus 35. And if you're looking at that saying, how is that an area? Well, it depends what the x values are. If x equals 1, then I plug 1 in for x here, and now I have the area when x is 1. So that's just the area of any shaded region between these two rectangles. Sweet. Simplicity at its finest. Remember, that's the most important part. The rest, it's algebra that you can roll with.